Bombelli is the father of complex numbers. Okay, now everything happens in a context. Right? Bombelli was going off what he read in Cardano's book. So we're back in Bologna here. Doesn't look like a very long life. His book, published in 1572, was just called Algebra. First European to systematically deal with negative numbers. You know, write down the rules. A negative times a negative is positive, that sort of thing. Dealt with complex numbers. How to add them, how to multiply them, how to subtract them, how to divide them. I don't know about square roots, I imagine he did. Yeah. So Cardano saw them as, oh, okay, we can sort of work with them, but they're useless anyway. He, called them sophistic, just an academic exercise, no meaning to it. Bombelli celebrated them. And his book was also notable for its down-to-earth writing. Other books, including Cardano's, were highfalutin academic language. I haven't read it, I'm not critiquing it personally, but Bombelli reacted to that. He did not have a formal mathematical education at all. He was an engineer, he developed an interest in mathematics, and he liked what he read and brought it down to earth. So a good expositor. And just a clear thinker with the complex numbers. It's a shame that his book didn't have greater influence, and that's perhaps partly because it was published in the year that he died, and he had further material in mind, which never got published but was then found in 1925. And so if he'd been alive to promote it, to engage in the community, then this book might have had more influence because, according to what I've read, even Euler, early in his mathematical life, made conceptual errors or had conceptual difficulties with imaginary numbers about what happens when you multiply two of them. How they don't obey the laws of multiplying two real numbered surds, right? Whereas that was all dealt with here. So if Euler had read this, then he would have got off to a better start. For more history, I recommend this paper. Complex and Unpredictable Cardano. It's not a difficult mathematical paper. It is by an academic, but he calls it a recreational paper. The name comes from the complex numbers and the probability. And the lovely thing is, it gives a lot of the biographical information. It doesn't go into heavy mathematical detail at all. It's all biography. There is so much more to the lives of those gentlemen than I've said today. And it's very interesting. But also, that article gives a nice demonstration, a nice understandable demonstration of how complex numbers are essential to quantum mechanics. And I've always been wanting to see information about how complex numbers are essential to whatever. And there it is, all right? It describes the double slit experiment and the probability that a particle will get to this position. And you cannot work that probability out without complex numbers. It's not like I've heard of electrical engineering, where we choose to represent, current as the real number and phase as the imaginary number or whatever, and then it makes our calculations easier. That's a choice, that's an arbitrary choice. I'm speaking with very little knowledge here, but that's an arbitrary choice. With the quantum mechanics, they could not work out those probabilities without complex numbers. It's not just a device to make things easier. So it's a good, that's a very worthwhile 12 pages of your time to be able to communicate something of that to your students. There is something in here for your students, good. And then chuck this in at the last minute. So it's, as I said at the beginning, it's in draft at the moment. So if you use the link, you can read the draft article. Once I've done all the reformatting and so on, then it'll appear in the conference brochure. So there we go. That is the end.